Hello and welcome to our presentation of the paper Finding Your Way Through the Jungle of Big Data Architectures. This is joint work of the St. Pölten University of Applied Sciences in Austria and Simplity, a consulting company in the data analytics field based in Czech Republic as well as Austria. I would like to thank the two co-authors, Sebastian Neumeier, also from the University of Applied Sciences in St. Pölten, as well as Stefan Markus from Simplity. So what we're trying to do in this work is to provide a bit more structured way of comparing, analyzing, and seeing the dependencies between the various analytical data architectures that have been proposed over the last few years. There are many buzzwords that definitely you have heard before, such as logical data warehouse, data mesh, data fabric, etc. And in order to kind of demystify those buzzwords a bit and provide a sound comparison based on a clear framework, we decided to use the elements of the DAMA wheel for data management from the DAMA DM book, as well as Archimate as a notation. And you see here on the right hand side there's basically elements like data integration and interoperability as an application function in Archimate terms, data storage and operations, as well as business intelligence, data science, more on the consumer side of things, metadata, data quality, data security. Those are all our functions that are expected to be provided by a data architecture. There's data sources, there's data consumers, and then there is additional capabilities also mentioned by DAMA, like data modeling and design, as well as data governance, which however are not necessarily components of a data architecture, but rather supporting capabilities. So this is kind of the framework we're using. And doing that, we started with the idea of a logical data warehouse, which was presented by Gartner in 2012, and then basically developed further over the years. The point of the logical data warehouse architecture is that classic architecture approaches such as data warehouse, data lake, data marts should not be seen as competing approaches, but rather as components that together can be combined in a common overarching architecture. As you see here in the middle, these are basically application components in Archimate speak of the data storage, or that provide data storage and operations functionality. There's different data integration approaches, from batch processing via stream processing to data virtualization, and of course things like that. Yeah. So this is the first example of a representation in this framework that we used. Moving forward, we then looked at the data fabric approach. This is a term that was originally brought up in various blog articles, but then again picked up by Gartner in 2019. The focus there shifted a bit away from a particular architecture or classic data storage paradigms like a data warehouse or data lake, rather to an overall infrastructure or platform where different storage technology was being used. You may have heard the term polyglot persistence, which is used here also in the diagram representing a polyglot data store. And again, of course, the different data integration approaches already mentioned earlier, plus the biggest part, or the big new element of the data fabric proposal by Gartner is the focus on metadata, and not just metadata in the classic sense, but basically they call it active metadata, which is basically saying there should be semantic metadata that enriches things like a data catalog and basically combines data meaning with physical representations of the data. Moving on, last not least, for this presentation, let's take a look at the latest proposal, data mesh, proposed by Degani in 2019 originally. Her point is that basically all centralized architecture approaches, being data warehouse, being data lake, etc., have more or less failed due to governance and complexity reasons, and that we need actually to look for a more decentralized way of managing data in the organization. So she introduces the idea of domain-driven design that is known from software engineering into the area of data management. And basically her proposal is that the different domains, the different business domains, should be responsible of basically managing and provisioning their data themselves, and the data should be offered as a product, basically. So she introduces the term data as a product with a common interface or standardized interface. This of course all only works if there is common standards and strong governance, as well as a common platform that would support the different domains in doing this, right? Another difference to the paradigms presented before is the idea that also operational data is included, and so also the operational data should be provided by the business domains as data products, just like analytical data is. And of course, they can also interchange data, so data from one domain can be used by the other domain. And again, there's a focus on metadata and semantic data metadata as well. Having that said, we started looking under the hood of those architecture paradigms and like comparing them and showing the dependencies. So obviously you see elements like data warehouse and data mart being reused in the concept of a logical data warehouse. You see batch processing, stream processing being used in something like a data fabric, but also in architecture approaches like Lambda and Kappa architecture, which we haven't really covered in this presentation due to the lack of time. Anyway, the point is we want to extend this this comparative view on the different architectures and basically point out more dependencies and overlaps between them, as well as extend this to a real something like a pattern system similar to the software patterns that we know from software engineering, where we provide a common form, a common template where you define the context, the problem, the solution that those architecture paradigms address, and therefore provide more guidelines or guiding in which architecture is actually most suitable for which situation, and also how maybe they can be combined and what are actually the building blocks of those architectural paradigms. And with that, I would like to thank you, and I'm happy to answer questions.